But now I'm going to teach you a way for you to think about all of this without worrying about ranges and without worrying about really any of this, because it's all going to become beautifully clear. For the LSP to hold, and this is the thing, I want you to remember all these words: exceptions rule, preconditions rule, postconditions rule, properties rule, exceptions rule, methods rule. I want you to remember all of those words, because those are words that software engineers at a certain advancement should know. But how you can have intuition about these is what I'm now going to teach you. For the LSP to hold all of those rules, tests within the specification of the superclass should still pass if the subclass is substituted. That's actually the whole LSP. That's the definition of the Liskov substitution principle, is if you write a test for your superclass, for the black box test, not like some I'm checking on my implementation. If you write a test for your supertype, it should still pass if you instantiate the subtype. And that's it. Now you've learned the Liskov substitution principle. That's the entire thing. So don't worry about those implementation specific tests. Those are special to the implementation. You don't have to pass those in the subtype. Like, there's no responsibility to you whatsoever. It's just the ones that are checking the specification. And this is why when we were talking about testing way back in the day, I said you want to keep those tests separate. You want to keep those in-spec black box tests in a nice spot that's different from your implementation tests, which are also very important for checking your coverage and getting, actually finding all of the rest of the bugs that your black box tests won't necessarily find, because they won't check all of the implementation level stuff. But a good reason to keep those separate is because you want to see whether those tests are failing on your subtypes. And if they are failing, then clients of your supertype will be unhappy when using your type. So this means that now when you think about, well, does this really limit me in the way that I can develop my subtypes? Is it about ranges? No, it isn't about either of those things. You just have to keep those tests passing. That's really it. So for those of you who made those statements, does that clarify things for you a little bit? Does that kind of help you out? Yeah, okay, awesome. All right, fantastic. So it's weird, right? When you see it, you like all of a sudden it just clicks. And it was funny because when I was realizing, like, I realized this kind of one day, I was like, wait a second, is this just that? And then I started looking through Liskov's writings on this subject. And I realized that actually she has also said this, except for she never put it together either. So she wrote a book on object-oriented design, and in her chapter on testing, she actually says the subtype inherits all of the supertype's tests. Black box tests, not glass box tests, inherits all of the black box tests. And it's like, well, that implies that it should be passing all of the black box tests, and that is the rule for substitutability. So yay, so now we have a really easy way of thinking about it. Liskov herself has said that this is the rule, except for she never squared the circle on that. So I did, and Alex Summers and I wrote a paper about how beautifully this works. So you can read our paper as well. Okay, so now let's look at so just to go through this slide, the subtype has to pass the supertypes tests. So when we're running our supertype tests, we of course instantiate our supertype if we can, if it's not an interface. We instantiate our supertype, we run our black box tests using the supertype instance, and they all pass. When we're trying to see if our subtype is substitutable, instead we declare the supertype, we instantiate it as a subtype, and then we run those black box tests, the super's black box tests, using the subtype, and those should all pass again. So the supertype's black box tests have to pass on the subtype. Everybody clear? Everybody with me? Yes, exactly. And that's why, so someone in chat says, That's why the penguin would fail the supertype test, because it would crash when you tell it to fly. That's right. It would pass the is this animal still alive test. It would fail that test. So the penguin, not a good subtype because it fails that still alive test. Square would violate because the rectangle test would be width has changed and height did not change on resize. So the resize test would look like width is the change width method should have the width change, and then it would have a check to make sure height didn't also change, because that's right in the specification. Only the width changes. And so the square would fail that because it would also change the height. So that's why it would fail. And so the cool thing is you can think about the fact whether it would pass a supertype test, and then you can kind of look through the litany of ways it might have violated the principle. You can say, okay, I know this isn't a subtype because I can imagine a black box test here that would fail. If I look at the specification, I can imagine it I can see that it's going to fail it. How exactly is it failing it? Oh, look, it's throwing an exception that's too much. So it's failing the exceptions rule. Or, oh, look, it's doing something extra. So it's changing the postcondition rule. Or, oh, I see, it's not even callable in all the same situations. So it's going to fail the precondition rule. So that's kind of how you can link that all back. So let's take a look at some examples just to really bring this home. So we have a restaurant, and the restaurant has a very narrow, a very specific specification. I guess all of them are, but it really has a specific one. It has a restaurant where you can book between the hours of 1900 and 2300 hours. We don't specify a close time, so we don't say that you have to only book. It's unlike the rectangle in this. We're not saying only from 1900 to 2300, but you have to at least be able to book from 1900 to 2300. And then we can write a test that checks that. We can say assert true, r.get booking 1900, we're doing our boundary checks. Basically, we're saying we're testing within the specification. We're not going outside. We're not saying it fails outside. We're saying, but inside, right at the boundaries, you should be able to get a booking at 1900 and 2300. This should all be safe. Great. Then we have our glass box tests that are hovering over here that are outside the spec, but we're not worried about those for the LSP. We worry about them for coverage and testing and all that good stuff. We're not worrying about them in the LSP. Okay, so then we might have another couple of restaurants, and those restaurants have different opening hours. So the broader restaurant is open a little bit wider than the regular restaurant. It's open from 1700 to 2400. It's a bit of a earlier start, later stop. Whereas the narrower restaurant is open for a narrower range of time. So, from 2000 to 2200 hours. All right. So what will happen with our tests? We don't need to worry. In the olden days, we would have worried, okay, is it going to be a precondition that's going to fail? Is it going to be a postcondition that's going to fail? But looking at just the tests and not worrying about which rule exactly is being violated, we can see what's going to happen. Because when we run our restaurant test on the broader restaurant, we can see that, will this one pass? Will we be able to get a booking at 1900 hours? What do you folks think? Yeah, we'll be able to get a booking at 1900 hours. Will we be able to get a booking at 2300 hours? Yeah, we will. Great. So our restaurant regular booking test passes. We don't really care actually about the subtype test that checks its own thing from the substitutability perspective. Clients of the restaurant only ever care about what the restaurant specified. They're not clients of the broader restaurant. They're clients of the restaurant. So they don't even know how the broader restaurant is doing what it's doing. They just know that they got it and that it's functioning according to the specification of the restaurant. Okay, so now counterexample, when we look at the narrower restaurant, will we be able to get a booking at 1900 hours? No, we won't. It's going to fail that one. It will fail and stop, but let's say it continued. Would we be able to get a booking at 2300 hours? We would not, because it closed. It was already closed. So even though the narrower restaurant is a good solution for itself, it passes its own tests, it doesn't pass the super types test. So a client will be very unhappy. It was expecting to be able to book at 1900 hours and it couldn't, so it failed that test. Yeah, that's right. These people, somebody said, because these people have no nightlife whatsoever. And it's absolutely true. They really, I don't know, are like, I don't know. It's a very strange restaurant that's very like precise. Okay. So that's really the whole LSP. And now, you can look back and say, okay, well, why was it that these things were violated in terms of the rules? We know that they don't substitute nicely. So this one was violated, and we know that. But now can we look back at our smorgasbord of rules and try and figure out which thing it violated? Like we know that it violated it, but which thing did it violate? Did it violate the exceptions rule? No. Did it violate the properties rule? No, not really. Yeah, that's right. So it wasn't the post conditions rule. I mean, maybe it was maybe it was actually the exceptions rule. If we look carefully at the implementation, which we don't have here, maybe it was that it was throwing an exception that says you can't book at that time. Is that what it was doing, actually? I think I might have had some code somewhere. Yeah, maybe like if it was throwing an exception that says you can't book at that time, then it would have been violating the exceptions rule. If it was, and then in so doing, it would have also been violating the preconditions rule. So it isn't just that it's doing one or the other. You can be violating in a couple of ways. So there's a lot of nuance. It really can be that you're violating in a bunch of ways, like you're violating the precondition rule and the exceptions rule because you threw an exception to show that you'd violated the precondition, and you'd violated the properties rule by not being open at the right times or whatever. So you're violating a bunch of those. And if you were asked on a test, which I'm not saying you will be, and you probably, I don't know if you will be, then you could tick off all of those and say, yeah, it violates all of those because of all these things that it did wrong. So it's not just one or the other. Okay, yeah, exactly. Okay, so what are the implications for testing here? The implications for testing are just to remember what we talked about even when we were talking about testing, which is to be very clear about what are in-spec tests versus the ones that are specific to your implementation. And those implementation ones do not need to be inherited. They don't need to be checked on the subtypes, but those spec tests need to pass on your subtypes. So it's a good thing to keep those separate so that you can see all of and can maybe even run them independently of one another. So, okay, first I'll check the black box ones and see that the subtyping is okay, and then I'll check these, or at least name them well enough so that you can tell, so you don't scare yourself and you're like, oh no, my subtype is, failing on this super type test, and oh, phew, it was just an implementation check. So just name them so that you have some reassurance from the names of your tests. The other thing that is a nice point of hygiene here, glass box. So someone says specification test, and the other one, it's actually just your black box tests that check your spec and your glass box tests that check your implementation. Another thing that's nice to remember is is a good idea when coding generally, and this isn't a learning outcome for this course, but I just want to say this tangentially, just because it'll look impressive at work, and maybe I should make it a learning outcome for this course, but really I'd have to bring Alex in for that. And that is to assert your preconditions. It's a snazzy thing to do. It's the way the world is going. To say, hey, these are my preconditions and I'm asserting those, so to make sure that the contract for this method is reached. It helps with checking your substitutability, because if you're not throwing an exception or failing in some way, if the precondition is violated, then your subtype won't necessarily loudly enough fail that super type test. It might get in and just do something that doesn't look like a failure. It'll just behave wrong, perhaps. So you kind of want to generally just hygienically do a fail if your preconditions are not being met. So just saying that's a little caveat about getting this testing approach to work in practice. Okay, what else did I want to say about this? Oh, yes. A lot of people are like, okay, so now we have this narrow restaurant. What do we do? We still want to have the narrow restaurant, like we don't want to chuck it out, but we can't have it be a subtype of restaurant because it's a lie. It's living a lie. It's not really a generic restaurant. So then what you do is you use delegation instead. You say, okay, a penguin is not a type of bird. A narrow restaurant is not actually a type of restaurant. It's something else. But it wants to use a lot of that excellent behavior that's provided by penguin, wants to use a lot of the stuff that birds do. Narrow restaurant probably wants a lot of the features of restaurant, like it wants to use the cooking facilities and probably maybe not the booking facilities, because that sounds like it's specialized, or not specialized, but different enough that it breaks it. But it might want to use like the seating arrangements or, I don't know, the hygiene habits or whatever it is that restaurants do, procurement of goods. So the refactored restaurant, what it would do is you would use delegation. You would have this narrow restaurant that has a field inside it, has an inner secret restaurant, and then you would just call over to it. So the restaurant would be used by the narrower restaurant, except for it would, like the narrow restaurant kind of puts a little bit of gatekeeping on the behaviors that it doesn't allow. So the penguin, for example, would not be substitutable for a bird, but you can still get a penguin, but it just wouldn't have a fly method at all. Like just not implementing a method is a good example of why you would need the LSP. Like if you just don't want a method to exist at all, and you're not going to throw this not implemented exception, because that would be a violation of the exceptions rule. You just make it a different type entirely. And penguin still wants to do a lot of bird things. So it has an inner bird and it calls over to bird to do all those things like eat and, I don't know, squawk, lay eggs, all these things that birds do. So you just make narrower restaurant a totally different type. Someone asks, what if another bird extends penguin? So it would have to be a type of penguin that extends penguin. So it could be a flying penguin. You could maybe have a flying penguin. You could have a penguin that flies. That would be an augmentation of the behavior. It wouldn't disappoint any clients. There's no rule that penguins can't fly. It's just that they don't have the behavior for fly. So a client wouldn't be unhappy if using a penguin, if it got substituted with a penguin that was augmented with flying ability, because it would never use the flying ability. So a penguin a client of a penguin would it wouldn't harm the nice person that they didn't throw the penguin out the window, right? Even if the penguin could fly, they would be like, well, I still don't trust you. I'm going to walk you downstairs. So you can augment behavior in a subtype and add as much new stuff as you want to. The client, you're not going to fail any of those tests. But if you wanted to take away behavior, now this is where you're getting into trouble with subtypes. Okay. So someone says, what if you change bird so it doesn't assume that it can fly anymore? Sure. If you want to change the definition of a bird such that it doesn't necessarily fly, that's completely fine. Then a penguin is substitutable for a bird. Absolutely. Usually, I think colloquially, birds are assumed to fly, but clearly not. Like they don't all fly. So we should probably change the definition of a bird. What you could also do is have an interface called flyer that most birds implement, but penguins do not. And then if you were expecting a flyer, you could throw that out the window and you'd be safe. So that's another way to do it. Yeah, exactly. I think we used the 210 flyer example, the flyer example in the 210 video. Okay, so some great questions. So are we like copying the code from bird to a penguin super type and just changing the one piece of code that says birds can fly to birds can't fly? I think the suggestion that I'm making is that you copy penguin over and you copy all of the public bird methods, except not the fly method. and you have a bird field inside of penguin. And for all of those methods, you just call the bird, you call inner bird dot whatever it is. You delegate over for every single one of those methods. So you barely need any implementation in Penguin except for the extra stuff that penguins can do that's super cool, like swimming for a really long time or whatever they can do. So you have all extra penguin stuff, but for anything that you would have inherited from bird, instead you call over to bird to get it done there. Does that make sense? So delegation often sounds like feature envy, but it's as much feature envy as you're going to allow yourself, basically. So if you're like grabbing stuff from bird and bringing it back and doing bird behaviors inside of penguin, those should probably move back to bird. So that's just about like, if you're changing bird behavior, where's that change going to be made? Everything that a bird should be able to do should live in bird. It shouldn't be brought back to penguin and also live a bit in seagull and live a bit somewhere else. So using another class through delegation or whatever is not necessarily feature envy. Feature envy is when you've taken on too much responsibility for a behavior that should live in another class. Okay, so someone says, I feel like penguin should be still a bird, but the client should now use a subtype called flying bird. And yeah, I think that's a great idea too. So I think what people are kind of suggesting is like, could you have, this is a really weird template suddenly, that's so bizarre. Could you have like a bird that has, let's put these behaviors in kind of a set of behavior that's like eat, swim, stuff like that. I guess it's a set, so we can do that. And then a big arrow to say penguin. And penguin is happy now because like penguin can eat and swim and that's what birds can do. But then you're saying you want a subtype of a bird called a flying bird. So bird, like, let's do this to show that we're subtyping. Flying bird. And flying bird could be an interface or it could be an abstract type, in which case this would be a good relationship. And then seagull would come off here, right? So I think that works too. So a regular bird, yeah, penguin's an example of a regular bird that cannot fly. A flying bird extends bird and also has fly in it. And then a seagull is an example of a flying bird. I love that. I think that's totally fine. That also works. Yep. Or you can have a flyer interface that forces everybody to define a fly method. But then, maybe you would want an abstract type that would actually supply that method, in which case this would be a nicer version of that. So I think I like this solution a lot. Yep. Okay, great. Any final questions before we close out for the day? Okie doke. Well, I think we're good then. It seems like everybody's happy. Somebody has asked whether a bird is a dinosaur. I think, yeah, I don't know. I think it's definitely inherits in the biological sense. I don't know that a bird would fit all the definitions of dinosaurs, except for, yeah, exactly. The Archaeopteryx for sure was a dinosaur, flying dinosaur, but not the pterodactyl, right? This is, it's all crazy. All your notes just say bird and penguin now. Fantastic. Okay, so feel free to ask questions in Piazza about all of this, just in case you get yourself confused. But just remember the golden rule here is this testing rule. This one is the one that you should remember, that tests within the specification of the superclass, black box superclass tests should still pass on subclass. And now you can forever remember the implications of the Liskov substitution principle. Okay, great. So thanks everybody. That was a super fun class. And I will see you all next week for more design principles. Okay, thanks folks.